characterize all the possible forces on all the possible surfaces, you need 9 components, each with 2 indices referring to 2 basis vectors. So for example, A sub xx might refer to the x-directed force on a surface whose area vector is in the x direction. A sub yx might refer to the x-directed force on a surface whose area vector is in the y direction, and so forth. This combination of 9 components and 9 sets of 2 basis vectors makes this a rank 2 tensor. This is a representation of a rank 3 tensor in 3-dimensional space. 27 components, each pertaining to one of 27 sets of 3 basis vectors. I'll zoom in a little bit here so you can see the components better. Notice that now each component has 3 indices. A sub xxx pertains to 3x basis vectors. A sub xyx pertains to 2x and 1 y basis vector, and so forth. This entire front slab has x as the 3rd index and pertains to these 9 sets of basis vectors. The middle slab all has y as the 3rd index and pertains to these 9, and the back slab all has z as the 3rd index and pertains to those 9. So in 3-dimensional space, 27 components, 27 sets of 3 basis vectors, and 3 indices on each component. You may be wondering, what is it about the combination of components and basis vectors that makes tensors so powerful? The answer is this: all observers in all reference frames agree, not on the basis vectors, not on the components, but on the combination of components and basis vectors. The reason for that is that the basis vectors transform one way between reference frames, and the components transform in just such a way so as to keep the combination of components and basis vectors the same for all observers. It was this characteristic of tensors that caused Lillian Lieber to call tensors the facts of the universe.